See tutorial 4. We're making a couple of small programs. One of them is going to convert Fahrenheit values into Celsius values, and the other is going to take a string of input from the user and count the number of characters on the line that they entered. These programs we're writing are really common programs to write when you're learning C. They're actually taken straight out of the original C programming language manual. For anyone interested in the C programming language manual, then I'll put a link to it in the description. It is an awesome book to read if you're learning C. Let's start out in our main method with a couple of variables. Let's make floats, Fahrenheit, and Celsius. So this makes two floats for us. It's just written out in one line of code. So we have float Fahrenheit and Celsius, which is also a float. This is our first time seeing floats in this video series. We've only used doubles so far. A float is pretty similar to a double in that it can hold decimal numbers. The only difference is that it's a little bit smaller, so it saves a little bit of space in memory, but you do sacrifice a little bit of accuracy when you're working with numbers that have lots of decimals. In our program, we're just working with small numbers and temperature values. We don't really care that much about the exact accuracy of like the 10th decimal point. So floats will do us just fine, and this gives me a chance to explain what a float is. Now we're going to make three ints. We're going to say int, lower, upper, and step. Lower is going to be where we start our table, upper will be the upper range of it, and step will be the increments that we show on the table. Let's give each of those some values. Let's say lower equals 0, so we'll start at 0 degrees Fahrenheit. Upper equals 300, let's step up by 20. And let's set Fahrenheit to the lower. So Fahrenheit is at 0 now while we start our loop. In our loop, we can just say while Fahrenheit is less than or equal to upper. And then inside of our loop, we'll just print out the Fahrenheit and Celsius values. The formula for Celsius given a Fahrenheit number is 5/9 times Fahrenheit minus 32. So that's Fahrenheit minus 32. So we're going to say Celsius equals, and we'll put both parts of our equation in parentheses just to make sure everything happens in the right order here. We'll say Celsius equals 5.0 divided by 9.0 times Fahrenheit minus 32. I'll just copy and paste that from the line above. So there's our Celsius value. The reason I'm putting 5.0 and 9.0 is because if we just put 5 and 9, then C is actually going to do something really weird called integer division, and the result of our division is going to be 0 because 9 doesn't fit into 5. But if you put on the point zeros, then C treats it as floating point division, and then it gives us a decimal result as the answer instead of just giving us 0. Now let's print out that Celsius value and the Fahrenheit value. We'll go printf quotations percentage 3.0f. The 0 just means don't print any decimals for the Fahrenheit values since they're just starting at 0 and going up by increments of 20. The 3 is the width of our number. So even though our lower is starting at 0, so Fahrenheit's going to be 0 to start with, when it prints out 0, it's going to take up 3 characters of space. So it's just going to pad it with white spaces. Once we make this, we can run it without the 3 here as well, just to see what that looks like. Then we'll go space percentage 6.1f, followed by a new line character. And then we'll pass in our Fahrenheit value and our Celsius value. And then on the next line, we'll just go Fahrenheit plus equals step. And we have printf, so we need to include stdio.h. And I'll save and run it. So we can see our 0 aligned itself with where the third character would be. So it just got padded with preceding white space. And then for our second value, the Celsius value, we put 6.1f. So it prints out using 6 characters of space. So that's why we have the white space between all of our Fahrenheit values and our Celsius values, because we said make this number occupy 6 characters of space. Let's change a few of the values inside of our printf statement just to see what happens. Let's go 1.0f and then run that. So the only difference we get is that our output looks a little bit wonky. The 0 hasn't aligned itself 3 characters over this time, and same with our 2-digit numbers. So everything still prints out, it just doesn't look quite the way we want it to. So let's change that back to 3.0f. Next, we're going to put a minus sign in front of the 3.0f. Minus sign just tells the value to align to the left. By default, it will align to the right. And the minus just makes it align to the left. Just so we can compare the two, I'll just copy and paste this while loop. And inside of the first one, we'll just leave it as it was normally. And in the second one, we'll leave the negative sign in there so that it aligns to the left. And I'll have to set Fahrenheit back to 0 between them. So the first one, where we didn't have the minus sign, the 0 automatically aligned to the right. That is aligning to the right inside of 3 characters worth of space, since we said 3.0f. And in our second loop with the minus sign, then the 0 aligned to the left, still taking up 3 characters worth of space. This time the padding white space just comes after the 0 since we used the negative sign. And just a little bit of terminology. This 3 is called the width, and the part that we place after the decimal is called the precision. And this entire thing is called the format specifier. I'll get rid of this bottom while loop now, and let's give our tables some headers. Just above our while loop, let's go printf quotation marks %s space %s, and then we're going to pass in Fahrenheit in quotations and Celsius in quotations. And if we printed this out right now, it would look pretty ugly because the table headers aren't going to align with the actual data in the table. So we have Fahrenheit with both values under it, and then Celsius with nothing under it. We also need a new line after our Celsius. So we'll go new line after the second %s. Instead of 3.0f, let's change our width to 15, just to leave us lots of extra room. And for our Celsius, let's go 10. And inside of our print statement for the Fahrenheit and Celsius table headers, let's also specify our width. We'll do the same values, just 15 and 10, just to guarantee that everything lines up properly. This will probably look a little bit spread out, but let's see, Fahrenheit is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters. So let's make the width for Fahrenheit 10 characters, and also change the value inside of our loop just to 10. This should look a little bit better now. We'll see if it's okay. That looks a lot better. Let's also print out a Celsius to Fahrenheit table now. So we'll go the other way, and I'm just going to copy and paste our original table, and I'll put a couple new lines in between just to keep everything looking clean. So we'll switch around this Celsius and Fahrenheit. And inside of our loop, this time the equation for Fahrenheit to Celsius is Celsius times 9/5 plus 32. So we have Fahrenheit equals parentheses Celsius times 9.0 divided by 5.0 plus 32. And we'll reverse Celsius and Fahrenheit in here. And we're also going to have to change the width of our format specifiers to match our columns now that we've switched them around. And let's say Celsius plus equals step. Let's change step before this loop. Just change it to, let's go with 5. We'll just go with smaller steps since we're in Celsius now. And we'll also have to change the value of Celsius before the loop. We might as well change the value of lower too. Let's go lower equals -50. And then Celsius equals lower. And let's change our upper Change the upper to, let's say 60 degrees. And then right now our loop wouldn't even execute because Fahrenheit has already hit upper. So we'll change Fahrenheit just to 0, just so that the loop will enter. And then Fahrenheit will just get a new value right at the start of our loop on the very first line. Let's run this with these widths that we have in here right now just to see if it looks okay. Doesn't look too bad actually. Celsius is a few digits too long. Celsius is 7 letters, so let's go 7.0f, and we'll also change that in our first print statement for Celsius to 7. Should look a little bit better. I should have just put Celsius in the while loop. That would have made a lot more sense instead of setting Fahrenheit to 0 and keeping it in there. Maybe you caught that, maybe you're thinking a bit faster than I am right now. But anyways, that's why it's going up to 20 right now. You can go ahead and change that in yours if you feel so inclined. Now let's write a little bit of code that gets the character count for a line of input from the user. We're not going to use scanf, we're going to use getchar. There's a few different ways to take in input in C. Scanf can be a little bit annoying sometimes depending what you're using it for. And I also want to show off getchar since scanf is all I've used so far. So let's put a comment, we'll just say counts the number of characters in a line of user inputs. And then we'll make a variable for holding the number of characters. Let's just make it an int. We'll say int character count equals 0. And then we'll say while parentheses. And inside of our parentheses for the condition for our while loop, we're going to say getchar and does not equal new line character. And this looks exactly the same as in one of the last videos when we used the same code to clear out the buffer. The only difference is this time we're going to increment a variable for every pass of the loop. So it'll take everything from the buffer, and every time it takes something, then it'll just increment our character count. Let's put ++ character counts, which is another thing we haven't seen in these tutorials yet. So far we've just done character counts ++. In this situation, they are going to do the exact same thing. The only difference between this, which is called prefix incrementing, and this, which is the postfix increment operator, the only difference is that for the postfix increment operator, the value of character count will be grabbed first before it's incremented. But if we have the increment operator prefix, then it's going to increment it and then grab the value of character count. In our case, it really doesn't matter because right here we're not grabbing the value of character count anyways, we're just increasing it. The only reason I'm using prefix is that in some cases, prefix is faster at runtime. So in cases when it doesn't matter whether you use prefix or postfix, then it's a pretty safe bet just to use prefix. We'll do a quick example after just to show what I mean by the difference between grabbing the value of character count either before or after it gets incremented. For now, let's just finish up this little block of code that's getting the number of characters. Let's go printf, quotation marks, %d, and we'll pass in the value of character counts. And let's just write, there are %d characters in that input. So let's print this out and see our character count. So our two tables will print from before. And then it's going to wait for us to put in some input since we called getchar and there's nothing in the buffer right now. So we'll put in our line of text and then it just tells us how many characters are in that line. There are 31 characters in that input. Let's look at the prefix and postfix increment operators now. Let's go int test1 equals 0. And then let's go printf quotation marks %d plus test1. And this is going to print out 1 because originally test1 is 0 and then we use ++ to increase it. And then printf grabs the value of test1, not until it's been incremented. And let's copy and paste that. And we'll go int test2 equals 0. And this time, instead of ++ test2, we're going to do test2 ++. This time the value of test2 is going to be grabbed first by printf, and then it's going to be incremented. And I'll just put test1 with prefix and test2 with postfix. So again, we'll get 1 with our prefix, and with our postfix, we'll get the value of 0 printed out. After this line is executed, then the value of test2 will be 1, but not until our printf has already printed the value of test2. Just to show that, let's put one more printf statement. We'll print out test2 again. And I'll just put test2 is now. Throw in some new lines in here so this isn't coming all out on one line. And give it some input. And we get there are 39 characters in that input. Test1 with prefix is 1. So test1, we did the prefix increment operator, which changed 0 to 1 before it printed out, which gave us the value of 1. Test2, we used the postfix, which printed out test2 while it was still 0, and then increased it. So it printed out as 0 and then increased it for the next line where test2 is now 1. That's it for this video. Thanks for watching. I'll leave a link to the next video in this series in the description.